In this problem, this is mass and pulley system. So threads are inextensible and massless as common in all pulley problems. So mass of these loads are given M1 and M2, and on this pulley, axle of this pulley, a force F is applied. And we are asked to find out the acceleration of this pulley. First, we will write equations of motion of those two blocks. Equation of motion of M1 and M2 by making their FBD. Then we will apply constraints, just these two things, and we will be able to solve our problem. So first of all, let's assume that tension in this thread is T. So now this thread is rolled over this pulley and comes down like this. So tension in this thread will be T because this is the same thread. And again, this thread is rolled over this pulley and attached to the ceiling. So tension here will also be T. Fine. If we look at this pulley, here tension is T. So in this string, there will be a tension of 2T, because if we make FBD of this pulley, if we assume tension is this thread to be T dash, so T dash will be equal to T plus T, so T dash equal to 2T. So here the tension will be 2T. Now look at this pulley. So there are tensions like this and this, and one force F is applied on this pulley, which is given to be 20 newtons. So F will be equal to 2T. This is our equation 1. So if I make FBD of mass M2, there will be tension T in upward direction, a force M2G in downward direction. So let's assume that acceleration of this mass is A2 in downward direction. So M2G minus T equal to M2A2. This is our equation 2. Similarly, we make FBD for mass M1. M1G will be applied in downward direction, and 2T will be applied in upward direction. So let's assume that acceleration of this mass is in upward direction and it's A1. Fine. So 2T minus M1G equal to M1 A1. This is our equation 3. So from equation 1, we know that 2T equal to F. So T will be equal to F by 2. So this T value we will be putting in this equation and this equation. So M2G minus F by 2 equal to M2A2, and F minus M1G equal to M1A1. So A2 equal to G minus F by 2M2, and A1 will be equal to F minus M1G by M1. So this will be equal to F by M1 minus G. Now we have written the equation of motion, the dynamic equation of motion for M1 and M2. Now we will apply constraints. So for applying constraints, let's see. So we have assumed acceleration of this mass as A2. So acceleration of this string will be A2, and this part of the string is attached to the ceiling. So displacement in this string will be equal to 0. So x equal to 0, x dot equal to 0, and x double dot is also equal to 0. So acceleration of this part of the string is 0, and we have taken acceleration of this block as a1. So what is a1? A1 is equal to acceleration of left string plus acceleration of right string by 2. So this is left string acceleration is 0 plus AR by 2. So 2A1 equal to AR. So we have got acceleration of this string as AR. Now, now we will look at this right pulley. This this string has acceleration A2 because this mass is having acceleration A2, and the left part acceleration, this acceleration of this string we have found out to be AR, and this pulley is being pulled with force F. Now with pulley constraints we know that acceleration of this point or this pulley will be left acceleration of left part of the string plus acceleration of right part of the string by 2. So AR plus A2 by 2. Left string has acceleration AR and right one has A2. So we know the value of this AR from this equation. So, and one thing, AR is in upward direction. Fine. So AR will be written with a positive sign, and A2 is in negative direction. So AR minus A2 by 2. So this will be equal to 2A1 minus A2 by 2 acceleration of this pulley. So now we will put the value of A1 and A2 in this equation. We have already found the value of A2 and A1. So putting the value of A1 and A2 in this expression, we will get this A equal to this. On simplifying, half I will take outside. It's already common. Then 2f by m1 minus 2g minus g plus f by 2m2. So this minus 2g and this minus g will become minus 3g, and I will take this outside. So this will be equal to minus 3g by 2 plus half into 2f by m1 plus f by 2m2. So simplifying this bracket, 2m1 m2 LCM 2 4f m2 plus f m1 in the numerator. So value of a will be minus 3g by 2 plus f I will bring outside 4m2 plus m1 by 4m1 m2. So this is our answer. Now F equal to 20 Newton and M1 equal to 1 kg, M2 equal to 2 kg, and G is given to be 10 meter per second square. So when I will put the respective values in this expression, A will come to be as 0.